All billahi minash shaitanir rajim. Bismillahirrahmanirrahim. So good day to each and everyone. Um so uh in this video we will continue our discussion for our previous topics, no? So we know that um last meeting or last season of our uh, classes, no? We have our prelim exams. Okay, so just a little reminders about our previous exams, no? So yung mga hindi pa nakatake sa inyo ng exams, I will be um posting some updates, no? But probably um we will be having our exam, special exam for those who have not yet uh taken their exams due to some reason, no? It's due to some valid reason. Okay, so we will be having our exam, special exam probably on after our final exams. Okay, so I will be giving some changes, no, changes to those who have not taken their exams, no, to take their special exams on after final exams. Okay, so just keep update kasi may mga possibles na hindi yun siya ma-follow, no? So, just giving you a reminders. Okay. For those na nakatake naman ng exams, um, currently I'm checking your exams, no? But due to no? Due to um, very very busy, no? There are so many uh, transactions and works that has to be done. Okay, so hindi ko pa masyado na lahat natapos. Okay, so anyway, no, just continuing our discussion or topics for this midterm coverage, no. So we will start, no, on our ME52. We will start on first law of thermodynamics and energy equations. Well, basically, this first law of thermodynamics talks about the conversion of energy from one phase to another. Okay, so it talks about the change of energy or conversion of energy. Okay, regarding on the uh, cycles that has to be done, no? So ibig sabihin nun, when we having a cycles, no, ibig sabihin from one state, no, papunta sa other state, then pabalik na naman sa original state. So yun yung tinatawag natin na scales. Lahat ng involving doon na changes of or conversion of energy from one form of energy to another's is actually yun yung pinag-aaralan dito. Okay, and then another one is that the conversation of energy, conservation of energy, I mean, no, when we say conservation of energy, um energy cannot be created nor be destroyed. So ibig sabihin nun, energy, no, energy is just, no, a matter where, or a phenomenon where it comes from the properties of a substance or properties of a materials, no, and then it cannot be created. So ibig sabihin, it is being stored or it is being transferred from one phase to another. Okay, from one place to another. So yun yung energy natin. So we have here the energy equation. Well, basically, no, energy equation is energy which is equal to internal energy U plus kinetic energy plus potential energy, no? So yan yung energy equation natin. So ibig sabihin nun, lahat ng energy when you have a system, no, lahat ng energy na involved doon sa system na yon is just the internal energy plus the kinetic energy plus the potential energy. Okay, so yun lang. Okay, so and then, no, since we are talking about here a system, okay, basically in this subject we are talking about the system. um okay, so it means that we have a transformation from one form of energy to another. Okay, so most probably, okay, most of the systems has their conversion from heat, no, from heat energy into um into a work. Okay? Or in reverse, no? So, ibig sabihin nun, pwedeng ang input natin is yung work, pwede rin ang output natin is yung heat. Okay? So, depends on the application of the system. Okay? So, um, just like for example, yung mga systems natin sa mga industrial companies, no? For example, the turbines, no? Yung sa Agus 1, no? Yung turbines natin doon, no? We have an input of a uh, we have an input of a steam, I mean a stream of water, and then it actually rotates the blades of the uh, turbines, and after that, no, that rotation generates a heat that converts that heat into a work. Okay, so yun, so lahat actually ng mga systems has their own heat, no? So that heat, no, whether it is being input or output, it is being converted on work. Okay, so yun, that's why kanina sinabi ko na energy cannot be created nor be destroyed. So okay, so yun, now um we have here a simple convention about the flow of heat and flow of work, no? So uh but before that, we have here a formula. So we have here a derivative of energy of a system with respect to time, okay, or heat or energy uh, rate is equals to heat rate minus the uh, work rate, no? Or we have here positive in minus negative minus out. Okay, so yun. So, this would be the general formula, no? So, lahat ng mga applications would be applied using this formula here, okay? But the convention, no, na minimin ko is that pag yung heat is in siya or input siya sa isang system, the sign of that heat particularly is positive, no? If it is out, no, or output from the system, no, its sign is negative. Take note that ang gagamitin natin na equation itong equation 3.3. Okay? And then for work naman, no, if it is output, no, if it is output, its conventional sign is positive, and if it is input, its conventional sign is negative. Okay? So take note of that sign convention of work and heat. Okay? So we have here, if we have to equate the energy that is being stated here sa equation number 3.1 and the energy that is being stated here sa equation number 3.3, if we have to equate that one, since they are all equal to energy, total energy of a system, so we can derive this equation here. We have derivative of total energy is equals to derivative of internal energy plus the derivative of kinetic energy plus derivative of potential energy is equals to um, uh, uh, gradients of heat and gradients of work. Okay. So now, what is the difference between this derivative and gradients here na sign? No? So ano yung sa tingin yung different nito? So why is it that hindi lahat D yung nilagay dito but meron pa tayong gradients here? No? So the reason why meron tayong gradient here is that dito sa equation number 3.4 is that yung du natin at saka d kinetic energy natin at saka hindi potential energy natin is depende yun siya sa path. Okay? Depende yun siya sa path kung saan nanggagaling yung or kung saan na-form yung kinetic energy natin sa yung potential energy. Whereas yung Q natin, it only depends on the final state, initial state or on the final state. Okay? So yun. But anyway, makikita din kung babasahin niyo yun siya, makikita niyo kung ano yung pinagkaibang dalawa. So that if you have to integrate that one, so um, meron tayong if we integrate that equation na previously, so meron tayong final equation of 1q2 and minus 1w2, or we have here, ibig sabihin nito, the work, the heat, no, the heat transfer from system 1 to system 2 minus the work transferred from the system 1 to system 2. Okay? So sabi dito, here the integration depends not only on the starting and ending state but also on the process path in between. Okay, no. Nagkamali pala yung discussion ko dito sa equation number 3.4, no? Baliktad pala yung equation number 3.4, kaya nagkaiba yung D natin at saka yung gradient natin. Yung D pala natin is yan yung nakadepende lang sa state, sa final state at saka sa initial state. Yung gradients Q natin or yung change of heat natin is nakadepende yun siya sa state natin, sa dalawang state, sa final state at saka sa initial state at saka sa path where it is being taken. Okay? So yun. So nakadepende, dalawa yung dependence ng Q natin at saka yung work natin. Okay? So yun, kung babasahin natin siya, maintindihan natin yung difference between Q, yung heat at saka yung work natin at saka with respect to internal energy natin at saka kinetic energy at saka yung potential energy natin. Okay? So yun. So basahin niyo na lang to yan siya. No, we have here an example here. So try this example number 1. So we have here example number 1 says that a tank containing a uh, fluid is stirred by a paddle wheel. No, the work input to the paddle wheel is 5,090 kilojoule. The heat transfer from the tank is 1,500 kilojoule. Consider the tank and the fluid inside the control surface and determine the change in internal energy of this control mass. Okay? So, yun. Determine the internal energy of this control mass. Yung U yung hahanapin natin. Okay? So, U2 minus U1 plus 1 half mv2 squared minus v1 squared plus mg z2 minus z1 is equals to 1 q2 minus 1 q1, no? 1 w1. So, we have here the change of, as you can see here, yung change of internal energy natin at saka yung kinetic energy, yung potential energy are all expressed in 2 and 1, whereas yung Q natin at saka 1 natin is hindi, no? So hindi, ibig sabihin lang nito yung internal energy natin at sa kinetic energy, potential energy are all depends on the final state and initial state. Okay? Whereas yung Q natin, work natin is hindi. Okay? So yun. So just substitute the value here, no? Since yung wala naman tayong involved dito na kinetic energy and potential energy, so cancel out na lang natin yung kinetic energy and potential energy. So only the remaining is U2 minus U1 is equals to 1 Q2 minus 1 Q1 omega 1 work 1 W1 or 1 work 1. 1 work 2. Okay? So we have here, since hinahanap natin yung change of internal energy, so we have negative 1,500 minus negative 5,090. Bakit negative 5,090? It is because yung work natin is input siya sa system natin, no? As we can see here sa problem, input talaga yung 5090. Okay? So from the other system to the system na kinonsider natin. And then yung Q natin, yung heat natin is negative din kasi instead na pa-in siya sa kuan, instead na in siya sa system natin, naging out na lang yun siya, no? Sabi dito, the heat transfer from the tank. So, ibig sabihin, ang direction niya is out, no? Or output from the tank. So, that's why negative. So, all in all, we have here 39, the change of internal energy, therefore, is 3590 kilojoule.